Hello everyone, thanks for attending Nullcon. My name is Timur Yunusov, my co-speaker Aleksandra Murzina, and today we will be talking how to unlock any door in 21st century, and we will be talking about biometrical systems and how they penetrated the market. I want to warn you, there is a disclaimer. At least 50% of this content was generated by the artificial intelligence, so we have no responsibility what you will see on the slides. So this project began in 2020. It's quite old. We haven't published anything up until now. We were working together in that amazing startup that's called Cyber R&D Lab. We were doing just purely security research until it's been banned by the US government and the organization dissolved, and we had to stop doing research. I was the head of research. Sasha was a senior male security expert. We were young and encouraged by trying to find some vulnerabilities. So we had this idea of utilizing her skills and trying to find what devices we can hack. So we saw a lot of new devices that use both biometrics and machine learning for doing authentication, authorization in buildings, and we bought a few of them and hacked them, and today you will see how this ended up. So in fact, different countries have different approach towards biometrics, and countries like Europe, they are more traditional, more conservative. They really don't want to do anything with biometrics. They're scared of GDPR violation, obviously want to have nothing to do with ML, so they're quite restrictive. On the other hand, we obviously have countries like Russia, China, who see this as an advantage. Yeah, you now don't need to take your card. We're going to Subway. Yeah, you just show your face, and that's it. And obviously, we all know these crazy pictures, videos from China, how you just go to kiosk, show your face, and get a drink, and lose a few points from a social score. This is basically, because of that, we decided, okay, we're going to get 3 devices from Europe. So we bought them in Europe from Amazon. They are predominantly made for European market. And we wanted to look at them and ask ourselves, well, are the politicians really right in that sense of having fears, or just all in their heads? So let's see.
Well, we have a wide range of biometrical methods, from physical ones and behavioral ones like some voice or how we walk. But today we are going to focus on something you probably use every day. It's facial recognition. It's changing the way we secure things and make life easier. And first picture the past. Early on, people manually measured some facial features like eye and nose distances in photos. And sometimes you can trace this method, how officers do this during some border controls. Then 2D and 3D face methods followed, helping computers recognize faces from different angles and expressions. But the real revolution came with machine learning from large data sets. This made face recognition much more accurate and powerful. To tackle tricky situations like low light, we started using special cameras that see depth and infrared light. This made face recognition work even in tough conditions. And now we can even teach computers to recognize emotions and on faces and check if face is real or fake. And sometimes people think that machine learning solutions are just one big black box. But in reality, they are a mix of different models and some engineering logic. Think about vehicle autopilots. They aren't just one thing. They use different sensors and clever logic to take you from point A to point B, just from one place to another. And the same goes for face recognition. To make sure you are recognizing somebody correctly, you have to go through a few steps. And these are steps. The first one is a face detection, when you need to find the face on the photo. The next one is face alignment. Once you find a face, we want to make sure it looks the same no matter how it's turned or how it's big. So we adjust it to a standard size and shape. Then goes very important step is feature extraction. This is where we get the special details of face, like shape of the eyes, nose and mouth. And during this step, we convert photo from some raw data to a vector of numbers. And as usual, this vector of numbers is stored to the database. And the biggest biometrical fear that these vectors can be leaked, and it could be reconstructed to the original data, like photo or fingerprints. And in such cases, you can change the password, but can't change your face or fingers, and that's a problem. But you can relax. Research showed that it's not easy to reconstruct these vectors with numbers to some original raw data. And then goes also very important stages like face matching and decision-making steps. Finally, the algorithm decides if the face matches someone we know. It might also say how sure it's about the match. This helps us make the right decision. And as usual, face matching stage gives us some probability. And decision-making stage, you have a threshold, some hard-coded or variable number, which is necessary to manage the solution precision. And when our solutions include machine learning, we must think about some additional security landscape that can apply to applications. When discussing machine learning security, the first type of attack that comes to mind for many is adversarial attack. Obviously. This involves the ability of mathematical algorithms to be triggered by small perturbations or changes. But however, adversarial attacks are just one small part of many possible options. This is my personal favorite scheme of possible attacks made 4 years ago by Kang Lee. You see that adversarial attacks are just one small part of possible attacks. And I guess if you are already in some machine learning security, you know this in details, and if you only start exploring this topic, you can just later use the link to explore better. This scheme is more about technology adopting to apps, and there is also some application-oriented scheme that I find very useful, like you already have an app, and what can go wrong? We already mentioned that ML or AI app, it's not just one black box. And something can go wrong from different components, and this is how you can develop a threat model from another perspective. And biometric systems are also like apps. And all of these are absolutely relevant to it. But it has some specific thing, and for that case, we are going to use this base model thread scheme. It's some collection of different schemes we see. Here you can see the basic steps involved in biometric face recognition and the way it can be vulnerable to attacks from different angles. Well, now the theory is over. It was important to ensure we are on the same page in terms of understanding. And now we can move on to our research. Let's discuss how to unlock any door in the 21st century. What we had? As Timur said, we had 3 devices. You can face it in your everyday life. The first one is a facial recognition access control device. You can meet in some airports, for example. Another one is a smart time control device. And the last one is a smart doorbell, which is some kind of popular IoT device. These devices have different prices, serve different purposes, and use different technologies. But if they have problems, all of them can unlock doors in certain private places. We are going to discuss all 3 devices, but due to time limit, we will talk in detail only the most interesting ideas what we had. Well, the first one, device. So the customer wanted us to check the security of this device. It's not just one device, actually. It also has some fingerprint component. But our main focus was on the facial recognition part. You can't just buy this device on Amazon or some other marketplace. It's expensive and used in places like airports and border controls, where security is a big deal. Luckily, we have our own lab, which gave us the resources to test it properly. And now what's interesting is that that device had some extra hardware features that weren't currently being used. But it seemed like the developers might have planned for some future upgrades. Among these, the most significant were a depth camera and 2 visible cameras. We did a deep dive into this and came up with a bunch of security-related ideas. Let's chat about 3 of the most interesting ones. This device had some classic vulnerabilities that allowed us to look inside the device. Well, the first assumption. When we look at how the device works, it starts by identifying faces in the frame, the first step. Then checks if they are live or not, just the second one. After that, it uses one of those visible light cameras, just one of them was for day and another one for the night. After that, it uses one of those visible. It goes through some standard steps like extracting features and comparing them to a database. What's wrong? Seems everything is fine. At the first glance, it looks like as it should be, right? But an interesting detail was discovered. So here's the deal. The depth camera wasn't actually used for feature extraction. It was just a separate state in the process. Now, if someone wanted to bypass this system, they could try some sneaky trick. You can stand in front of the depth camera like a regular person, while showing the required image to the visible light camera. Now, did we tackle this? How did we tackle this? Well, we placed a small piece of glass between 2 cameras. And that's it. Actually, why don't they use the depth data? Just, you know that it's not so easy to run some complex algorithms on such small devices. That's why, we guess. Also, we found some bug in business logic. If there are multiple faces in the frame, the algorithm chooses the bigger one. Well, in this case, you don't need any special equipment to bypass the face recognition. And now something that really caught our attention. So here is the scope. At first, we found a remote code execution vulnerability in the terminal, but honestly, it didn't excite us. We decided to dive into how the biometrical algorithm works, especially when we don't have info about the users who store it in the database. We were thinking that the learning algorithm should be the same, just consistent across all the devices. And then we had some wild idea. Could we make universal face that could unlock any of these terminals? The algorithm had magic threshold number 2500 hard-coded into it. It uses for making final decision. This means we needed to generate an image score at least this number. So here's what we did next. We came up with some smart optimizing algorithm and used variational autoencoder along with a high-resolution technology to create a face that could score the threshold. Variational autoencoder is a type of generative neural network which allows to generate new images. To make it work, we first train the autoencoder using data set of faces called Sleba-A to help it learn how to restore images from some noise. Then we applied the face super resolution algorithm called SPAR-NAT to increase the image quality. And after it, we ran it through the autoencoder and fine-tuned for a high score of 2500. Was it successful? In digital, yes. It's not a problem to generate such a face, but when you move into the real world, the quality and score should be much bigger. Just because different light and noise can impact the quality of recognition, and even you have a bit score, it can fail. Well, small devices lead to certain assumptions that impact security. Today we discuss biometric security, but some of the vulnerabilities were more traditional, like remote code execution, which gave us the opportunity to quickly exploit the biometrical algorithm. And we had the second device. This is a device for tracking employee working hours. It's pretty straightforward. You come up, look at the camera, and it decides whether to grant access or not. This device is special because it uses only an infrared camera for its biometric system. The key point is that it doesn't see things the way we do. So trying to trick it how we did won't work. Of course, the terminal had some classic vulnerabilities that allowed access to its algorithms. This machine learning algorithms based on Gabor filter and local binary pattern. It all worked together. We are not going to go deep into these algorithms, but there is the thing, they are really sensitive. Even small changes like wearing or taking off glasses can confuse them. So, after looking into these machine learning algorithms, we decided that they weren't what we needed. We shifted our focus to figuring out how to bypass the depth camera instead. How to get around. Our researcher was inspired by how an LED screen works and thought, what if we made a special screen for the terminal with only one picture on it? LED lamps are seen as inefficient because they emit a lot of their energy in the form on infrared light, which isn't very useful for illumination. That is, conditionally, we need to emit depth for the infrared camera, but how could this be done? Our researcher had a neat idea, printing a photo on some transparent film and then shining an incandescent light through it. The black parts on the film would create a depth-like pattern. Overall, it worked, and once again, the terminal was quite sensitive to changes. This made it challenging to use in practice and even test it. We found logical flaws in the terminal, which allowed us to test it in more detail. We tried displaying a unique image on transparent film lid with infrared light, and it works. However, the terminal was sensitive to changes, such as recognizing the same person differently with or without glasses, for example. Despite this, the combination of technologies like Gabor filters, local binary patterns, and infrared camera offers robust security.
So, you all know that IoT devices like doorbells, smart cameras, they are almost become the intrinsic part of our lives. Yeah, they're everywhere. So 3 years ago, when this research started, literally Sasha and I, we sat together and decided to find some device on Amazon that has few important things. First, it should have the word AI, ML on it, and it should be used for some kind of facial recognition. Yeah, so we saw these trends a few years ago, right before we started this project. Every IoT vendor decided, that's a really nice idea. Let's start implementing AI, ML on our devices, raise the price twice or 3 times, and that's going to be amazing. So that's why it was quite easy. We opened Amazon, entered ML, camera, recognition, and we found this little fella, UFI, quite popular model, especially in Europe, literally says human detection, snapshot recognition, blah, blah, blah. So vendors add AI to the device or ML. Obviously, product becomes more complex. Yeah, it now needs not only to send images, needs to store it safely. So is it more secure now? That's what we are trying to find out. So vendor has quite strong opinion on their device, and I'm quoting, it's a smart doorbell, high-tech home security device, offer HD video, motion detection, local storage, and obviously it's a privacy focus because it's meant to operate in Europe where GDPR affects everything, robust encryption, military-grade security, and what's more important, it cannot be hacked. So, alright, we thought, let's have a look what you brought to the market. So, problem number 1, when you connect this device to your Wi-Fi network, allows you to conduct man-in-the-middle attack because there is no SSL check-in process, no SSL pinning, meaning every time device boots, it starts knocking, asking for firmware, so I can get this firmware, and firmware is very secure. Again, it is signed with MD5, meaning if I'm creating my own firmware and uploading it to a device, it also will work very nicely. Next, this military-grade encryption we were so excited to hear about. So yeah, all videos, all photos, they stored on 4 GB smart hub that should be sold separately from now on, yeah, because you add more complexity. And there is actually IS 128 encryption, which is almost impossible to hack until these days at least. But there is a problem. The key generates when you launch the hub first time, and it uses the srand pseudo-random generator, which is quite weak itself. And next, it used the source of entropy as the local time, not even in milliseconds, just in seconds, meaning that it takes around 30 seconds to find out the encryption key for every device in the world and decrypt all the videos that are stored on the smart hub. 13, obviously, so how it works. Yeah, someone rings the bell, you get a notification on your mobile phone, and in the history, you're going to see all the faces to see, yeah, that was an Amazon driver, that was someone else, yeah, they stored there indefinitely. To execute that, vendor decided to upload all photos in AWS, yeah, and the UFI server generates the signatures for AWS uploading and downloading functions, so basically acts as a proxy. The problem is that there is a past reversal in signature generation function, meaning that using these 3 symbols, ... you can actually try to get access of snapshots of every device in the world, anyone who uses UFI doorbells. So, quite good. Point number 4, because we used our colleague at times from CyberLab, Pedro Umbellino, and he is a physical and security engineer. We obviously wanted to look at the device from the physical point of view. Yeah, so by that time we already had firmware, we already had remote code execution, but still. So on the back of the device there are 6 pins, very nice. You didn't need to even unscrew anything, and there is an unlocked USB OTG debugging interface, which gives you a direct access to the shell. So it's going to be full access to the Linux machine. You can get access to all the firmware binaries, download them, and have a look. And that was the moment when we found this file, model.bin.tar. We're like, oh, at last we can look at how ML works. But only by that time we realized that all ML in the device is not like a real facial recognition. So all these algorithm do is just detects if there is a human or no human. Yeah, you can pretend to be a boss, I don't know, but what's the point? By that time, device was completely nailed from every point of view, so we decided, well, probably not a good way to move forward and spend our time trying to hack ML here. But the good thing is that these days UFI provides actual facial recognition devices, so if you are willing to spend another £1,000, you definitely can get into this research and finalize things that we haven't done. So it took us 3 years to get any responses from them. It was extremely slow. We were trying to reach out to them using Chinese CERT, obviously like a lot of email communications. That's the last one, saying, hey, we're gonna fix our vulnerabilities within the next update, kind regards. We don't know. Did they fix it? Did they not? At this point, we don't even care. So Pedro made the presentation about hacking this device in 2021. He has a lot of slides on his GitHub page, so if you want to have a look, download the slides. In fact, UFI had a lot of questions and concerns from a security researcher since 2021. There's been a lot of questions like, hey, this device sends data to AWS without permission. And UFI was saying, hey guys, we're going to be more transparent, more open, initiate bug bounty program. That never happened. At the beginning of this project, we had a few assumptions, like some of them actually changed at the end, by the end of it. Some of them were quite accurate for what we thought in the first place. So newer, better, more secure, obviously not correct. Yeah, everyone is trying to add technological advantage as a way to increase profits, but a lot of people forget more technology, meaning more attacking surface, more ways to hack the systems. So think twice before you implement AI on your device. Next, there is also a perception that the more advanced ML you use, the better. Yeah, and the more resilient it is to different attacks. Everyone is trying to use the most modern systems and technologies that are invented literally like last months, yeah, and relevant AI systems. Sometimes, actually, older means better, it's more robust, more resilient to different attacks. Again, think twice. And finally, cheap devices, less security. Well, what do you expect from a device that costs less than $5 to the manufacturer? But again, it's not also always correct, because it should be like a very subtle balance where you don't invest a lot in technology, in security, and trying to overlook some low-hanging fruits. So again, it needs to be balanced. You know what? We were trying to write a white paper for 3 years. We cannot disclose one of the vendors, as you saw. So we ditched that idea. That's all you get. You get a security checklist for checking biometrical systems. That will be it. Obviously, the slide is going to be published, yeah, but unfortunately, that's what you get. Want to say thanks to everyone who participated in that project, and Cyber R&D Lab, rest in peace. Thank you. I have an announcement that has nothing to do with this presentation. I have Payment Village stickers. If you want to get one, come to me. I have a bunch of them left. Any questions not related to Payment Village?
Any questions, anyone? Any questions at the back? No? No questions.
Thanks so much.
Thank you for your such an insightful talk.
There is a hand. Don't, don't applaud yet.
So I came in the mid. Maybe I would have missed starting 10 minutes. So my question is like, is there any way to bypass the door locks which has the password?
Door locks that has the password?
Yes.
To be honest, have a look at Pentest Partners blog, because they regularly do that. So they work with like smart door locks that use like pins or mobile apps, and there is a bunch of ways of doing that. Again, it's a good example of you mess up so robust technology that worked for centuries by just adding technology to it. Yeah, you add Bluetooth to your lock, you screwed.
Yeah, thank you.
Thanks so much.
Thank you. Any other question?
Hello, interesting talk. So I had one question. You were trying to make a universal face with the first lock, right? That can basically you were trying to generate a face that can unlock the lock, right? So you said that in your model architecture, you were trying to get that 2,500 score for by testing it on the model for a device. Now, that would change depending on the faces that have been stored in that device, right? So now, if I add a new face there, won't the threshold also vary? You won't get the same universal face, right, for that device. It will depend on the faces that have been stored on that device. So,
first of all, obviously, the threshold, 205,000, is unified across all the photos. Yeah. At the last step, how Sasha was trying to explain, when all the features extracted and vectors are compared, there is a question of what is probability that the face A is the face from one of the databases. And there is a number that says, hey, the probability is 100, the probability is 2000. So this exact device has this threshold. If the probability of the face that you present is more than 205,000, this is the face that's stored in the database. Now, when we were trying to create these artificial faces, universal faces, we were able to achieve that score. That the score basically saying anyone, well, I don't remember about like anything in the database, probably would choose some, the most relevant again, yeah, with the most score, but it still allowed us to get score and try to bypass that and basically be one of the persons in a database. Yeah, if you have millions of records there, you probably have higher chance to find, to be matched against one of these people. If you have only 10 records there, which we had, that was slightly lower. But the last problem was this transition between the virtual reality when we created these faces, an actual person who would be looking like that, who we struggled to find because this person didn't exist.
Thank you.
Okay, so my question starts with the threshold only, so I think you partially answered it. I just want to know like how you guys identified that threshold value was 2,500, and is it like common known thing, or it was there in the documentation, or?
Can you repeat it again, please?
So you were talking about the threshold for the first device, the facial recognition of the device where you bypass it with a universal face. And you also spoke about the threshold, which is 2,500. Now, the question is around like how you identified that specific sweet spot or the threshold value. Like, is it like universally common known thing, or it was documentation you found out?
Again, the whole idea, all three of these devices had the remote code execution in it. So we were able to extract all the models, all the firmware, all the code. Without that, it's obviously a black box. Yeah, but that was the whole idea of this research. If we are able to get access to all the internals, yeah, so there you go. Checklist, firmware. Try to download the firmware, try to extract it from a device, try to get it from anywhere. And this will give you next steps. This is not a broad information. 205,000 is dedicated to this specific vendor, to this specific model. Maybe they will raise it after this presentation.
Hey, thanks. So, do you have plans to continue your research for the, let's say, mobile devices as well? So, as of now, all these devices are fixed devices, and let's say when you talk about security, let's say if there are proximity sensors as well, just in case somebody wants to break in by spoofing face or something. So, like, my question is more around like mobile devices, as can be your mobile, or probably, I don't know, like laptops, what you're carrying using face recognition.
This comes from time to time, all these nice ideas. Basically, you have this technology, new technology, like, oh, we need to go and try this. Yeah, so when Moscow subway introduced the facial recognition systems, you're like, oh, we need to go and try it. Yeah, but some systems you cannot get off Amazon, you cannot get off eBay. If you can't get it, the value in such a research also not quite high. So it all depends of whether we'll be motivated enough for doing that. But I agree, like, go and research. That's an amazing idea. This is why we are trying to present these things, to explain people that it's quite easy to start going and doing this.
Awesome. Thanks, guys. Is your white paper already published for reference?
Slides gonna be published. I don't need to speak to the guys. Reach me out like Twitter, or I will give you my details, and I will keep you updated.
Thanks.
Hello, sir. It was a nice presentation. So how did you actually create this universal face? Is there any approach of creating it, or was it based on the existing data, or how exactly it was?
Of creating what?
Universal face. Universal face that we have created, like it was, there's a brute force of fuzzing of the faces, right? Yeah, there's, no.
What? Which one?
No, before.
Yeah, that's what I thought, universal face.
Yeah,
This one, right?
Yeah, this one. How did you create this face?
So there is a big database data set of the faces called CLAB-A, and basically use SparNet. So SparNet is used mostly for generating deepfakes, and it's you can run it in Python using Google Colab. You can obviously try to run it on your own devices. Yeah. So this one was pretty common subset, that set, and the network we used.
Okay, and one more, like since you were able to intercept the traffic, did you ever get a chance to performing a response manipulation kind of thing so that we can bypass the facial recognition with a success response?
That was at the very beginning of the project. Yeah, we were like, yeah, we're definitely going to get to that. But by the time we got to actually being able to execute that, the attacking surface became so wide, so we focused on something else. And because that was like a real project, we had quite strict deadlines when we needed to present it to the customer. So it's a nice idea. Go and do it.
Yeah, thank you.
Thank you.